XEV YOYO. The 3D printing industry is developing so fast that now it's possible to print fully functional cars. The Yo-Yo from the British company XEV Limited is one of the world's first cars to be mass-produced in this way. Yo-Yo is ideal for big cities. It's small, less than 2.5 meters long, which makes it easy to park. It stands out for its eco-friendliness thanks to its zero emission level. Inside the cabin, you'll find a 7-inch screen, a 10-inch touchscreen, an AC system, and a panoramic roof. The technical features are impressive as well. The maximum speed is 80 km per hour. The cruising range exceeds 150 km. The trunk has a capacity of 160 litres. The weight of the car is only 450 kilograms. It's powered by an electric motor with a capacity of 7.5 kilowatts. This car was created with the 3D printers from the German company Big Reb. The experts used the G2 series equipment developed especially for such large format projects. They have an enclosed build chamber and the best print head in its class. Aurora and Stratasys UAV. In 2015, a team of engineers at Aurora Flight Sciences, which specializes in the creation of unmanned aerial vehicles, approached Stratasys to create the world's first 3D printed drone. You can see the result on your screen. The drone has a wingspan of 2.7 meters and weighs 13.6 kilograms. Thanks to its low mass and electric motor, the top speed is more than 241 kilometers per hour. This is amazing, considering that 80% of its components were all 3D printed. The Fortus 450MC industrial printer did most of the work. Its main task is to produce prototype parts for testing and functional trials. It's also perfect for manufacturing tooling, one-off items, and end-use parts. In other words, it's impossible to find a more suitable machine to print a drone. The printing material is Stratasys ULTEM 9085. It's a lightweight, non-toxic thermoplastic that has high thermal and chemical resistance. Stratasys anatomical models. Here's another interesting project from the Israeli Stratasys team that caught our attention. This time, the specialists teamed up with the Jacobs Institute to improve medical equipment used for teaching. They created ultra-realistic anatomical models using the new Stratasys J750 multi-material 3D printer. With them, new surgeons can immerse themselves in an accurately recreated surgical scenario without risking a real person's life. The traditional anatomical models that doctors use for training are far from resembling real bodies. Fortunately, 3D technology is here to change that. Stratasys J750 makes it possible to print any part of the human body for training. The printer combines several types of materials to recreate different types of tissue, such as bone or muscle. The key difference here from the competitors is its biomechanical accuracy. It's possible to print the bones of a 20-year-old and a 70-year-old person, reflecting their structural differences. MX3D Metal XL. Many people think that only soft materials, such as plastic or silicon, are suitable for 3D printing. However, there is one company that has chosen to specialize in creating stainless steel parts. Today, we'll talk about two projects from the Dutch company MX3D. The first dates back to 2015, when a group of students from the Delft University of Technology designed and then created a fully functional steel bicycle. Thanks to the help of the experts at MX3D, the work was completed in a total of 3 months. You can see the ARC bicycle on the screen. It's the world's first bicycle created with 3D printing techniques based on MIG welding. Also, the bike was created to draw attention to another project of the company, and at the same time to showcase the technology suitable for creating large metal objects. Since October 2015, an experimental bridge has been under construction on one of Amsterdam's oldest canals, the Oudegids Achterbergwal. The bridge elements are created with a 3D printer. Due to the complexity of the project, the specialists have had to collaborate with other companies. For example, Hyman serves as a construction consultant, Lenovo is responsible for the computing equipment, and ABB for the robotics. The individual approach applied to the creation of the 3D printer makes it possible to build truly complex and elegant yet durable structures. Apis Core. 2 years ago, the Dubai municipality contracted Apis Core to build a 2-story office building. The resulting structure is the largest 3D printed building ever. It's 9.5 meters tall and has a floor area of 640 square meters. The building was erected directly on the construction site without any additional setup. It was made out of a gypsum-based mixture developed by Apis Core specifically for this project, taking into account the hot and dry climate of the city. The printer uses a rotating extruder that deposits the material layer by layer, gradually increasing the height of the walls. Compared to traditional printers, its dimensions are outstanding. It's 5 meters long, 1.5 meters wide, 1.5 meters tall, and weighs 2.5 tons. However, given the functionality, it can be considered quite compact. Open Bionics prosthetic limbs. Bionic prostheses can be very expensive, ranging in price from $35,000 to $120,000. Fortunately, the British company Open Bionics has found that the use of 3D printing technology can reduce the cost of a single prosthesis to $1,200. The final product is designed for patients that still have an elbow joint, but miss anywhere from their hand upwards. In addition to the prosthesis, special sensors on the arm read electrical signals passing through the muscle and allow the hand to be controlled as if it were real. The fingers move independently of each other at different speeds and are capable of a wide variety of movements and types of grips. Since they're supposed to be the most flexible parts, they're made of Polymaker TPU95A thermoplastic polyurethane and are printed with functional joints. The other parts of the prosthesis, which must be more rigid, are created with Polymaker PLA, a biodegradable and biocompatible polylactide. The raw materials are derived from corn and sugarcane. Ingersoll Masterprint. The next project we're going to show is the world's largest 3D printed polymer boat. Its unique feature is its one-piece hull. The project was launched by the University of Maine. The boat, measuring 7.6 meters long and weighing 2,267 kilograms, was unveiled in October 2019. It was made thanks to the Masterprint 3X printer. It's the world's largest polymer 3D printer and is capable of printing 30-meter-long parts. The printer was developed for the space, aerospace, automotive, and naval sectors. The extruder has a capacity of 68 to 453 kilograms of material per hour. At the same time, it reduces production costs by 90% because it eliminates the need for cutting, welding, milling, and other complex processes. D4K Pro Dental. The international company Envision Tech has succeeded in creating a desktop 3D printer capable of printing dental prostheses with high precision and speed. The D4K Pro Dental is built on an industrial 4K DLP projector, so the developers guarantee the stability of its operation for many years. The device is compact, relatively easy to use, and designed for use in dental practices. It works with a wide range of materials, more than 10, to create various prostheses and implants. For example, E-Denstone, a photopolymer used to print dental diagnostic products, or E-Orthoshape, a photopolymer for thermoformed aligners. Terran R Hex. This groundbreaking project was announced just a few weeks ago. The experts at the Californian startup Relativity Space have managed to create a reusable two-stage rocket built entirely with a 3D printer. This is the second rocket created by this team. Unlike its predecessor, it's a more advanced and environmentally friendly solution to improve the industry. The first launch is scheduled for 2024. Terran R is 66 meters tall and 4.9 meters wide. The maximum payload is 20 tons. Several proprietary alloys developed specifically for this project have been used to manufacture the rocket. Compared to conventional designs, the advantages are enormous. Ordinary rockets contain more than 1,000 parts, while the Terran R has fewer than 1,000. Usually it takes 2 years to build a rocket like this, but the Terran R can be built in 2 months. The downtime between rocket construction is usually 2 years as well, but in the case of the Terran R, it's only 6 months. The new Roar. Today's last project was launched by a Dutch research and design studio to raise awareness about plastic pollution. It all started in 2017, when the first recycled bench was placed in the center of Amsterdam. An amount of plastic equivalent to 3,000 plastic bags was used to create it. That's about 50 kilograms of shredded plastic, which took 6 hours to print. Today, there is an entire laboratory known as the Zero Waste Lab in the city of Thessaloniki in Greece. There, residents can learn how to recycle plastic, drop off waste plastic for recycling, and even participate in creating their own furniture designs. The studio also creates benches with built-in plant pots, which are installed on the waterfront.
Hey, stop